Okay, so welcome back to our notes on writing polynomials. And in example 2, we want to write the equation of the polynomial in standard form given these real zeros in the verbal description. So this polynomial, it has a leading coefficient of 1, right? We want the polynomial of least degree, and its zeros are 0, so I have a cross here at 0, and 2, but the 2, it says, is a double zero, a double root. So at 2, I have multiplicity of 2, and that's going to be a bounce, right? So I'll have a cross at 0 and a bounce at 2. So when I, in step 1, list the zeros with multiplicity, x equals 0, and x equals 2 with multiplicity of 2. Okay, now when I go to write this in factored form, my x is a cross. It's a linear factor, so it doesn't need an exponent written with it. But this x equals 2 corresponds to a factor of x minus 2, and that is a double root, so it gets an exponent of 2. And then we have our y equals, or f of x equals if you're using function notation. And it says that my leading coefficient is 1, so that's a positive leading coefficient. This is an odd degree. 1 plus 2 is 3. So odd degree and leading coefficient that is positive means that my end behavior is going to start down and end up. So when I go to sketch this graph, since it's starting down here on the left, my cross is going to have to go from left to right, increasing. Okay, and then at x equals 2, it's multiplicity 2, so it's a bounce, and that bounce has to face upward so that my end behavior works so that it ends facing up, right? So starting down and ending up. And that would be a rough sketch of my polynomial. So when I want to rewrite this now in standard form, starting with my factored form, I need to remember that when you have a binomial squared, you cannot distribute that exponent. Instead, you have to expand your polynomial. So y is equal to x, and then this is an x minus 2 times another x minus 2. Now, those of you from Algebra 2 who remember your shortcut for a perfect square trinomial, maybe from here you already see that that's x squared minus 4x plus 4, but if not, if you're a little rusty in your algebra, we'll go ahead and FOIL this out to show why that's working. So x times x is x squared. Then we have x times negative 2, negative 2x. Then that was first outer, now inner. Negative 2 times x is another negative 2x. And the negative 2 times negative 2 is a constant of positive 4. And when we combine those like terms in the middle, negative 2x and another negative 2x, right, that doubles the middle here to be x squared minus 4x plus 4. And there's that perfect square trinomial shortcut that we just talked about a moment ago. You learned in Algebra 2 that when you have a binomial being raised to the second power, we call that a perfect square trinomial. You can square the a, you can square the b to get your constant, and then you multiply a times b and double it to get your middle term, right? Or if you don't like the shortcut, just go ahead and FOIL and combine your like terms. So now we got to bring down this linear factor of x, and our last step then to get rid of these parentheses is to distribute this monomial to the trinomial. So x times x squared is x cubed, then x times negative 4x is a negative 4x squared, and x times a positive 4 is a positive 4x. And remember, standard form is going to be in decreasing order of exponent. So we've got our cubed, then our quadratic, then our linear terms. Okay, and that would be the polynomial of least degree that has a leading coefficient of 1, zeros of 0, 2, where 2 is a double root. So go ahead and try this example on your own on some scratch paper, and then you can resume the video when you're ready to go over it together. Okay, so we're back. We want to write a polynomial of least degree. Leading coefficient is 1, and the real zeros are x equals plus or minus 1, each with multiplicity of 2. So in factored form, I would have a factor of x minus 1 for the x equals 1, 0, and that has multiplicity of 2. And then a factor of x plus 1, also with multiplicity of 2, right? Those are my real zeros, plus or minus 1, each with multiplicity of 2. Then I also have a 0 at x equals plus or minus square root of 6. Remember, that's a conjugate pair. If you have an irrational 0, it must have its conjugate with it. So that's going to produce a factor of x minus the square root of 6, and another factor of x plus the square root of 6. And those do not have multiplicity, so they're just linear factors. Okay, so this would be my polynomial in factored form that produces this graph. The square root of 6 is 2.4-ish maybe, so somewhere in here. We'll go ahead and put a real 0. Then negative square root of 6 would be negative 2.4-ish, somewhere over here. X equals positive 1, and x equals negative 1. Okay, and the degree, 2 plus 2 is 4, plus 1 is 5, plus 1 is 6. So this is an even degree, and it has a positive leading coefficient, and so both ends are going to point up for the end behavior. Okay, so when I do my bounce wiggle cross, I see that I have a cross at the negative square root of 6, so that's going to head this way. There's a cross at the positive square root of 6, so whoops, missed it. So that's going to need to head up this way. Then there's a bounce at each of these zeros of plus and minus 1, and since this cross starts up and ends down, in order to hit the bounce here at negative 1, that bounce has to head downward. Okay, and then same thing for this one. In order to meet up, I would need to have my bounce facing downward, like so. So now that I've got my my directors here on my axis, I can go ahead and sketch my polynomial so that we've got 2 bounces and 2 crosses, and there's the end behavior, both ends pointing up. Okay, so to write this polynomial in standard form, I'm going to need to expand these into from a difference of squares into their expanded form. So here I have an x plus square root of 6, x minus square root of 6. That's a difference of squares, difference of perfect squares. So my shortcut for a difference of squares, if I were to FOIL, right, to do it the long way, I'd have x times x is x squared, then a positive square root of 6x, a negative square root of 6x. Those would cancel in the middle, and then a square root of 6 times a square root of 6 on the end, which would be a negative 6. So rather than FOIL that all out, since I know the shortcut, the middle always cancels, I'm just going to go ahead and use that shortcut to go to the square of the first, which is x squared, minus the square of the last, and that would be a 6. So x squared minus 6 is the reduced form of this difference of squares. Okay, when I look over here at the beginning, I have two perfect square trinomials if I wanted to treat them that way, or it may be easier actually to see that this is also a difference of squares, right? X plus 1, x minus 1. And so since those are a difference of squares and there's two of them, I have two difference of squares. So that would be an x squared minus 1, and then two of them because there's multiplicity of 2. And so now that is a perfect square trinomial with an x squared minus 1 on the inside. So when I square the first, I get x to the 4th power, right? Then I multiply and double, so that would be a minus 2x squared in the middle, and then square my second one, so negative 1 times negative 1 is a positive 1, and that's my constant, and this would be my, I've evaluated those difference of squares and perfect square trinomials. So y is equal to this trinomial now times this binomial. And then I need to expand this by doing some repeated distributing. So x to the 4th times x squared. When you multiply the same base, you add the exponents. And so now I'd have y equals x to the 6th, right? X to the 4th times x squared. Then x to the 4th times a negative 6 is going to be minus 6x to the 4th. Okay, then we have negative 2x squared times x squared is a negative 2x to the 4th. And then negative 2x squared times negative 6, a negative and a negative is a positive 12x squared. Okay, and then one more time with our constant, 1 times x squared is positive x squared. And then we have 1 times negative 6, which is a minus 6. And now we can do some combining like terms. So y is equal to, and there's our x to the 6th in the front. Then we've got a negative 6 to the 4th and a minus 2x to the x to the 4th. And so those are like terms. And when we combine those like terms, negative 6 plus negative 2 is a negative 8x to the 4th. Okay, and then we're going to combine this 12x squared plus x squared, since those are like terms, and we'll have a plus 13x squared, and then our constant at the end, which is minus 6. And that would be polynomial of least degree with a leading coefficient of 1 and real zeros of x equals plus or minus 1, each with multiplicity 2, and then 2 zeros at this conjugate pair of plus and minus square root of 6. So that brings us to the secret question for this lesson. You're going to write a polynomial function of least degree with a leading coefficient of 1 and real zeros of x equals 0 with multiplicity of 3. And then you've got your two irrational zeros here in a conjugate pair, x equals root 2 and x equals negative root 2. So we're going to sketch the graph. The zeros are labeled for you so you know where to put those square root of 2 and negative square root of 2. You're going to tell me what the degree is of the polynomial. You're going to write it first in factored form and then expand it and combine your like terms, write it in standard form. Okay, once you've got those all finished up, then you can upload that result as the last page of your notes in Schoology.